Download this code from codegib.com, link in the description below. Certainly. Grbl is an open source firmware that is widely used to control CNC machines, such as milling machines and laser cutters. One of the common issues users may encounter when working with Grbl is alarm 2. This error typically indicates a problem with the machine's homing cycle or the need for a reset. Understanding alarm 2. Alarm 2 is specifically related to the homing process. It usually means that the machine is unable to find the home position during the homing cycle. This can happen for several reasons, including 1. Limit switch issues. The limit switches may be malfunctioning, improperly connected, or not triggered. 2. Incorrect settings. The Grbl configuration might not be set correctly for your machine. 3. Physical obstructions. There may be physical obstructions preventing the machine from moving to the home position. 4. Wiring issues. Loose or broken wires can lead to communication problems between the control board and the limit switches. How to resolve alarm 2? Here are steps you can take to troubleshoot and resolve alarm 2. 1. Check limit switches. Ensure that all limit switches are properly connected and functioning. Manually trigger the limit switches to see if they register as expected. Use a multimeter to check for continuity in the switches when triggered. 2. Examine physical setup. Make sure that there are no obstructions preventing the machine from moving to the home position. Check the machine's mechanical components for any binding or resistance. 3. Verify Grbl configuration. Connect to your Grbl control software, like Universal Code Sender, and check the configuration settings. Use the command $$ to view the current Grbl settings. Example output: $0 equals 10, step pulse time, microseconds. $1 equals 255, step idle delay, milliseconds. $2 equals 0, step port invert mask. $3 equals 3, dir port invert mask. $4 equals 0, invert step enable pin, boolean. $5 equals 0, disable stepper motors, boolean. $6 equals 0, probe pin invert, boolean. $10 equals 3, status report options. $11 equals 0.010, junction deviation, mm. $12 equals 0.002, arc tolerance, mm. $13 equals 0, report in inches, boolean. $20 equals 0, soft limits enable, boolean. $21 equals 0, hard limits enable, boolean. $22 equals 1, homing cycle enable, boolean. $23 equals 0, homing direction invert, mask. $24 equals 25.000, homing feed rate, mm/min. $25 equals 500.000, homing seek rate, mm/min. $26 equals 250, homing debounce, milliseconds. $27 equals 1.000, homing pull off, mm. Ensure that the homing settings, like $22, $23, $24, $25, $26, and $27, are set correctly. 4. Reset the Grbl controller. If you have made changes or if the machine is stuck in an alarm state, perform a reset. You can reset Grbl using the command $$ to check settings or by power cycling the controller. 5. Test the homing process. Once you have checked everything, try to run the homing command again. $h. This command initiates the homing cycle. Watch for any unexpected behavior or error messages. Example code snippet for homing. If you are using a control software like Universal Code Sender or similar, you can start the homing process with the following command in the console. Code G28, go to home position, G-code command. Conclusion. Alarm 2 in Grbl indicates an issue with the homing process, typically related to limit switches or configuration settings. By following the troubleshooting steps outlined above, you should be able to identify and correct the problem. Always ensure to check your machine's physical setup, wiring, and Grbl configuration to prevent and resolve this error effectively.